Hello, this is Richard Jacob from Matrix Science. In this presentation, I'm going to give an overview of the MS²PIP peptide spectrum predictor and how it is used with Mascot server. So, what is MS²PIP? It is one of the components of the MS²RESCORE pipeline, integrated into Mascot server version 3.0. The other component in the pipeline is DeepLC, which you can hear about in other videos. MS²PIP predicts MS2 and MS3 fragmentation patterns, including fragment ion intensity, using one of 13 models. The top 10 matches for each query, as found by Mascot, are compared to their predicted spectra generated by MS²PIP. MS²RESCORE evaluates the correlation between the predicted and observed spectrum, calculating 71 features such as the Pearson correlation coefficient, Spearman correlation, and dot product. MS²RESCORE passes these features along with others generated by Mascot server to Percolator to rescore all the search results. In order to use MS²PIP, the search has to include a decoy result. This is now the default setting for Mascot searches. Here is an example of a labeled spectra from a match identified by Mascot server. The peptide sequence was passed to MS²PIP along with which model to use and the predicted spectra generated. If you want to peek under the hood, you can use the online service MS²PIP server to generate spectra for you in different formats. The real spectra is compared to the predicted spectra, and 71 features are calculated from the match and passed to Percolator, along with the standard 24 features from Mascot server and 6 from DeepLC if used. Mascot server ships with 13 MS²PIP models. Which one should you use? Either in the search form or post-search, select a model that is close to the experiment design and instrumentation. The CID model is a good starting point. For Orbitrap instruments, start with an HCD model, HCD 2019 or HCD CH2 model, or try the iTrack or TMT models if you are using reporter ion labeling. The model does not have to be an exact match, and there is a description of the models on the Predicting Retention Time and Spectral Similarity with MS²RESCORE page. Here is the interface in the search form. Just a checkbox and a couple of drop-down boxes. The MS²PIP is marked in red. You can also apply it to an existing search result. Select it from the box and click Apply. If you are running the search through a browser or processing a completed search, you will see the Percolator progress as part of the cache creation progress bars. After the search is completed and Percolator has run, you can evaluate the results. Click on the Machine Learning Quality Report link to see how it did. The overview page of the report displays the improvement in peptide spectrum matches and peptide sequences, along with graphs of the target and decoy match score distributions. The best quality control graphs are on the Rescoring Features tab. On the left, the performance of all the different features is reported. If you mouse over the feature, the name of it will display. The individual feature performance plot shows the strength of individual features. Then, the area under the curve, AUC, is calculated for the empirical cumulative distribution function, ECDF, of the Q values. The higher the area under the curve, the better the feature is at discriminating between target and decoy peptide spectrum matches without any other information. The strongest MS²PIP feature is SPEC-Pearson norm, unfortunately not labeled, which is the Pearson correlation between the predicted and observed spectra. This is shown on the right. The peptide spectrum matches that pass the 1% false discovery rate are plotted, and a median value of 0.8 or better is considered a good correlation coefficient. Now that we know how to evaluate the results, one question that comes up is which model to choose. The good news is that a badly fitting model rarely makes your results worse. At the moment, we don't have a quick way to find the best model. However, you should be able to determine suitable models for your instrument using standard experiment conditions. Typically the CID or one of the HCD models. If you have a timsTOF, then try that model. Likewise, if you are labeling with TMT or iTrack, then use the appropriate model. We applied all 13 models to an example dataset. This is a CPTAC yeast example that is acquired with a Thermo LTQ XL Orbitrap. We've used this example in a couple of other articles on our website, as it is small enough to quickly iterate through all the models. The number of significant unique sequences is taken at 1% sequence false discovery rate. The baseline performance is with refining enabled and neither DeepLC nor MS²PIP model selected, which yields 2,740 significant sequences. So the relative increase in significant unique sequences in the table is purely down to the MS²PIP model. The models are sorted by the improvement in significant sequences from the top left to the bottom right. Some models show a relatively poor median Pearson correlation coefficient, which still have a significant improvement in the number of sequences identified. This is because the Pearson correlation coefficient was probably not the major feature used by Percolator when rescoring the results. What we can see from this overview is that the models offer some improvement, but the further we go away from a straight CID model, the smaller the improvement is from the model. That wraps up the quick introduction to MS²PIP peptide spectrum predictor and how to use it with Mascot Server version 3.0. If you have any questions, please contact support@matrixscience.com and we will do our best to help.